Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we will find polar form of some complex numbers. Let us take a complex number and we will convert it into its polar form. Here we have complex number z equal to -1 minus iota square root of 3. Now in this case, a real part is equal to -1 and imaginary part is equal to minus square root of 3. To convert this complex number into polar form, we put real part equal to r cos theta, that is r cos theta equal to real part, that is -1, and we put imaginary part equal to r sin theta, that is r sin theta equal to minus square root of 3. Thus we get z equal to, instead of -1 we have r cos theta, or cos theta plus iota. Instead of minus square root of 3 we have r sin theta, or sin theta. Now take r common, it's r times cos theta plus iota sin theta. Now this is polar form of the complex number z, while r is modulus of the complex number and theta is argument of the complex number. Now we have to find r and theta. Now to find r, squaring and adding these two equations, we get r square cos square theta plus r square sin square theta is equal to -1 square is 1 plus minus square root of 3 square is equal to 3. Take r square common, so we have r square times cos square theta plus sin square theta equal to 1 plus 3 is equal to 4. Now cos square theta plus sin square theta is equal to 1, so we get r square is equal to 4, or r is equal to square root of 4, that is equal to 2. We take r as positive because it is modulus of the complex number and it cannot be negative. Thus we get modulus of the complex number, that is r equal to 2. Now we have to find theta, that is argument of the complex number z. For that we use r equal to 2 in these two equations, so we get here we have, instead of r we write 2 cos theta equal to -1, or cos theta equal to -1/2. Okay, now in this equation we use 2 instead of r, so we get 2 sin theta is equal to minus square root of 3, or sin theta is equal to minus square root of 3 divided by 2. Okay, now cos theta is negative, also sin theta is negative. That means theta lies in third quadrant. So theta lies in this quadrant, that is quadrant third. Now our real part is -1, so if we start from origin, we have to move towards real axis, towards negative real axis, 1 unit distance. So this is 1, and imaginary part is equal to minus square root of 3. So we move towards negative imaginary axis equal to root 3 distance. So it is root 3 distance. So we reach it here. That means the point corresponding to the complex number z is this point, say point P. Okay. Now join point P with the origin. Then if this is O, then if we write this as equal to A, then OA is equal to 1 unit and AP is equal to square root of 3 units. Okay. Let this angle be equal to alpha. Now we have to find theta, and theta is this angle. Okay. But we first find angle alpha. Okay. We know that tan alpha is equal to opposite side, that is square root of 3 divided by adjacent side, that is 1. So that is equal to square root of 3. And we know that when tan alpha is equal to square root of 3, then alpha is equal to 60 degree or pi by 3 radians. So alpha is pi by 3 radians. Now we have to find theta, and theta is this angle. Okay. Now we know that this angle is pi, then we have pi plus pi by 3. So this angle is pi plus pi by 3. It is pi plus pi by 3. So that means pi plus pi by 3. That is equal to 3 pi plus pi, that is 4 pi by 3. Okay. So the whole angle is equal to 360 or 2 pi. So if we have to find this angle, this is equal to 2 pi minus 4 pi by 3. That is equal to 6 pi minus 4 pi. That is equal to 2 pi by 3. But in this case, we are moving in clockwise sense, and in clockwise sense, the angle is negative. So we have to take theta equal to minus 2 pi by 3. So theta is equal to minus 2 pi by 3. Now r is equal to 2 and theta is equal to minus 2 pi by 3. So we use these two in this equation and we get z equal to, let's write it here, z is equal to, instead of r we have 2 and cos, instead of theta we have minus 2 pi by 3 plus iota sine minus 2 pi by 3. So this is the polar form of z, while 2 is modulus of the complex number z and minus 2 pi by 3 is argument of this complex number. This completes the question. Now let us take one more complex number. Here we have complex number z equal to minus 1 plus iota. In this case, the real part is equal to minus 1 and imaginary part is equal to plus 1. Now to convert this complex number into polar form, we put a real part equal to r cos theta. So r cos theta is equal to minus 1 and imaginary part equal to r sin theta. Imaginary part is equal to plus 1. Okay, thus we can write z is equal to r cos theta plus iota or sine theta, or we can write z is equal to, take r common, it's r times cos theta plus iota sine theta. Okay, now here r is modulus of the complex number z and theta is argument of the complex number z. And we have to find both r and theta. To find r, squaring and adding these two equations, we get r square cos square theta plus r square sine square theta equal to minus 1 square is equal to 1 and 1 square is equal to 1. Now take r square common, we have cos square theta plus sine square theta equal to 1 plus 1 is 2. Okay, now cos square theta plus sine square theta is 1, so we get r square equal to 2, or we can write r is equal to square root of 2. We have to take positive sign here because r is modulus and modulus cannot be negative. Okay, now we have to find theta. For that, we use r equal to square root of 2 in these two equations. Now here instead of r we can write square root of 2 cos theta equal to minus 1, or cos theta is equal to minus 1 by square root of 2. Also here instead of r we can write square root of 2 sine theta equal to 1, so that means sine theta is equal to 1 by square root of 2. Now cos theta is negative and sine theta is positive. That means theta lies in quadrant second. So real part is equal to minus 1. That means we have to move from origin 1 unit towards a real negative real axis. So let this be equal to 1 unit. And imaginary part is equal to plus 1. So we have to move towards positive imaginary axis equal to 1 unit. Let this is equal to 1 unit. We name this point as P. Then the point P is the point corresponding to this complex number. Okay. Now join origin with this point. Let this be O. Okay. Draw perpendicular from this point on real axis. This is 1 unit. This is 1 unit. Let this angle be alpha. Okay. Then tan alpha. Write it here. Tan alpha is equal to opposite side, that is 1, divided by adjacent side, that is 1, so which is equal to 1. And we know that when tan alpha is equal to 1, then alpha is equal to 45 degree or pi by 4 radians. Now we have to find theta. That means we have to find this angle, theta. So theta is equal to the whole angle, that is pi, minus this angle, that is pi by 4. So that is equal to 4 pi minus pi, that is 3 pi by 4. So theta is equal to 3 pi by 4. Thus we get modulus, that is r, equal to square root of 2 and argument, that is theta equal to 3 pi by 4. Now we use these 2r and theta in this equation, so we get z is equal to, instead of r we have square root of 2, then cos of, instead of theta we have 3 pi by 4 plus iota sine of 3 pi by 4. So this is the polar form of this complex number with modulus equal to square root of 2 and argument equal to 3 pi by 4. That completes the question. Now in my next lecture we will do some more questions on complex numbers. Till then, take care of yourself. Thank you.